Just like our transistors, diodes play a major role in all the electronics industry. Diodes are used in many circuits that are built for different types of purposes. It acts more like a transistor, and if you haven't seen the working of it, click on the I button to watch that video. Coming back into our topic, in this video we will see what a diode is and its working. You're watching Beyond, and let's get into our topic. A diode is a two-terminal device and it has an anode and a cathode. The diode is defined as a semiconductor device that has two terminals and can conduct current only in one direction, due to which a diode is also known as a unidirectional device. However, for a diode to conduct current, it must be within a specified voltage level. The diode is derived from diode, which means it's a device that has two electrodes. The symbol of the diode is as follows, and it's just like the LED. If we remove the emitting arrows, the symbol is same as the diode. The diodes are made up of semiconductor, and the commonly used semiconductor is silicon. As discussed in our earlier video about transistor, we saw that pure silicon doesn't have any free electrons. However, we won't be using pure silicon. We will add impurities to it. This process is called as doping. One part is doped with N-type impurity while the other is doped with P-type impurity. Once the doping is done, at the N side we will have free electrons, and at the P side we will have vacant holes for the electrons. After this, due to a small attraction at the borders at N and P side, few electrons from N side travel towards the P side. This makes the P side slightly negatively charged. Similarly, the N side will become slightly positively charged. This creates or forms a depletion layer which opposes any further migration of electrons. We can say that a potential barrier is built for electron flow, which is approximately equal to 0.7 volts. Now, if we apply an external source with negative to the P-type and positive to the N-type, then the holes and electrons gets attracted towards the supply. This which in turn increases the depletion layer. Due to this, the electricity flow becomes impossible. This condition is known as reverse bias of diode. When we reverse the external supply, that is, the positive of the source is connected to the P-type and the negative of the source is connected to the N-type. Now the situation changes. The negative supply pushes the electrons inside, and once the supply is greater than the depletion region, the electrons flow into the holes at the P side. Again, due to the positive charge, the holes remain the same while the electrons jump into the other set of holes until it reaches the positive terminal. This condition is known as forward bias. At this condition, the depletion region reduces completely and allows the electrons to flow continuously. This is the reason we say that the diode is a unidirectional one. Now, if we see the diode characteristics, when reverse voltage is given, it allows only a negligible current which is of no use and almost equal to zero. But when we apply a forward voltage, it has a steep increase in the current flow within the circuit. This current flow is obtained only when the forward voltage is above 0.7 voltage, below which it is again negligible. A diode, however, cannot cross 0.7 voltage even when a higher voltage is provided. This is due to the N forward biased condition. The diode offers very low resistance against the current flow. When a high voltage is given in the reverse condition, it would damage the diode, which will lead to a high current flow. The working of the diodes are quite different and interesting, due to which the diodes are used in few applications such as bridge rectifier, where AC is converted into DC, and even in our mobile charging circuits. Hope this video was helpful to you to know about the working of a diode. Thank you for watching this video. If you like this video, hit that like button. Don't forget to subscribe to my channel and hit that bell icon next to it to get instant notification whenever I release a new video. Do share it with your friends and comment on what we need to speak next. Until then, don't forget to think big.